Hello, I'm Nicholas.
And I'm Kirsten, and this is Anthropo Snips, where we explore recent ish papers surrounding anthropogenic impacts on natural ecosystems. Hello, beautiful people. Welcome to our number four, Anthropo Snip.
Hello.
That was a very delayed hello, Nicholas.
I was breathing in to get that nice, deep, peanut buttery hello.
Who uses peanut buttery as a.
There's peanut butter in my peripheral vision, so.
Okay, I just see this romantic novel written by Nicholas, like his peanut buttery smooth voice. Oh God. Okay. So, hey, tier number 3 membership is you get to listen to Nicholas read his romantic novels that he's writing, that he
It's
has to
it's
write.
literally just it's me reading the nutritional facts on a jar of creamy peanut butter in a deep voice.
That could be a thing. Be careful.
Oh,
All
whatever,
right.
somebody's fetish.
Anyway, guys, we are now on a roll of starting our anthroposnips on weird little tangents, which I'm kind of a fan of, but you let us know if we're annoying you. Our paper today is by Trammell et al. 2020. Check it out in the show notes. And the title is Temperate Deciduous Forests Embedded Across Developed Landscapes. Younger forests harbor invasive plants, and urban forests maintain native plants. Now, I reached into this paper because it seems pretty counterintuitive, which is what makes it so interesting. So just hang in there and I'll break it down.
My brain is just going off a mile a minute. I have so many theories already.
That's good. Hang on to the edge of your seat and we'll see if any of your theories are correct or if you're just have the Monday night sleepies.
You know what? I'm going to write down my theory so you know that I wasn't lying in case I'm right.
Okay, ready? All right. Well, Nicholas is writing. I just quickly want to thank Dr. Trammell for giving me access to their paper. So I reached out via ResearchGate, which we mentioned in an earlier Anthroposnip, and they sent me the paper so that I could get into it. So thank you very much. It was super interesting, and I'm really glad that I can share this with you guys. So the idea starts with this, right? Temperate deciduous forests are one of the most densely populated biomes in our whole world. This is where people live, and if anybody doesn't know what I mean by biomes, like a biome is the temperate deciduous forest versus the desert versus the tropical rainforest. So different regions in the world that are defined mostly by their abiotic factors like temperature, rain, and then also by the plant life that lives there. But these ones are the most inhabited by humans. Now, they are also sometimes called temperate broadleaf forests, and they're found obviously in temperate regions, mainly in the northern hemisphere, with a few pockets in the southern regions as well. They're found in eastern North America, midwestern Europe, parts of Russia, and eastern Asia. Now, the southern groups, there are little pockets in Australia, New Zealand, and then the southernmost parts of Chile as well, because you kind of get this same sort of seasonality that if you think about like Northeast United States kind of thing, that also happens in these pockets. Now, they are forests that are dominated by broadleaf angiosperm trees instead of pine gymnosperm trees. I'm going to do a tiny little aside in case people aren't super familiar with trees, just on the different definitions. So we have angiosperm and gymnosperm trees, right? Angiosperms are trees that produce flowers and then fruits for reproduction, and gymnosperms are cones, right? So they're often called conifers. Then you have deciduous and evergreen trees, which most of the time when you think of gymnosperm trees, you always think evergreen, but that's not always the case, which is weird. But so you have deciduous trees are ones that seasonally lose their leaves, and that's either based on dryness or cold. So in some parts of the African savanna, there's certain trees that lose their leaves in the dry season, or the very classic trees changing colors and losing their leaves in the fall in the temperate deciduous forest. And then you get evergreen trees, keep them all year. Now, these can be leafy angiosperms or they can be the conifers that we're mostly used to, right? Up in the boreal forest, you get those really Classic ones. Now, total aside, but in Siberia, there is a deciduous gymnosperm called the lark or tamarack. And these ones lose their pine needles too because it gets so cold that it's just too hard for them to even conserve their pine needles. So there is such thing as deciduous gymnosperms. Anyway, back to the study here. So this study focused on the north and eastern United States, and 93% of temperate deciduous forests in the USA are now less than 50 hectares large. So we have tons of really small pockets of trees, but you don't get these really nice continuous ecosystems anymore. I really quickly wanted to mention that I know a lot of times we are focusing kind of in the Americas. I think that's just kind of where our experience is, but I promise our invasive species worldwide will extend a little bit more past that at some point.
Worldwide, wide, wide, wide.
Exactly. I just, as I was writing this up, as I was researching for this, I was like, I promise I'm going to look at other places, but all the things that I know lots about are in my natural habitat, right? So, anyway.
That's how people compartmentalize things. I mean, that's just what we naturally do. Obviously, we're trying to explore other parts of the world, and we will be definitely getting into other parts of the world in some of the upcoming full episodes. So definitely stay tuned for that. And I mean, we've already been exploring the world. We just compare it to what we know, and that's our best way of educating you about the different areas. So, of course, there's going to be some lack of understanding in certain areas. Maybe if you're from a different part of the world that we're talking about, you're going to be like, these guys are idiots. I can't believe they don't know that. Well, we just haven't been there and haven't experienced it. So give us a little bit of a break. We're doing our best. And that's all you can ask.
Don't use the words idiots. Nicholas will cry.
Yeah, that is like my least favorite word, actually.
It's not a very nice word, is it?
I will actually cry.
Oh man, I'm sorry. But yes, so back to northeastern United States temperate deciduous forests. So essentially, this really dense population of humans in all these areas leads to a bunch of really tiny forests throughout urbanizations. Think about like your urban parks and between developments, between farmlands. And in theory, these little pockets are extra sensitive to invasive species because they're likely are disturbed and under more stress. And they have kind of this more edge habitat where different species can come in and invade, right? Now, also in the paper here, it is seen that seedling success of native trees has been shown to be impacted by urbanization and by invasion. So by having these two factors here, we're worried about having native plants and then also having the native plants be able to reproduce and establish in these areas, right? So then the paper wants to understand how these disturbances impact the native assemblages and the respective ecosystem services, right? So when we're talking about ecosystem services, we're talking about filtering water, about how trees help to control microclimates. So it's cooler, in the park on a sunny day, you sit under a tree, that's like an ecosystem service, all these different things, right? Essentially, as most of the time you'll see, having better native biodiversity generally helps have better ecosystem services, right? So we know a bit about this, but definitely lacking some information on community structures and effects on the ecosystem processes with disturbances. So why do we care, though? That was the big thing. So species composition is essentially equal to the forest function and the services, as I'm sort of repeating myself. But we also need to be able to understand how forests change with time and with these impacts so we can better compare the impacts of urbanization and invasion. So when we're doing any kind of studies on this thing, when you get too many variables, it can be really hard to study impacts because you have a lot of things interacting and kind of confusing with each other. So if you understand better how each system or different systems behave, then you can create models or use assumptions to kind of standardize things, which helps you to study better, right? So the more studies we know or we do to understand like the different aspects of these things, we'll know more and we can study more, right? And then if you try to see if anthropogenic change and development and invasion do go hand in hand, right? Are they related? Are they to be treated differently? Are they correlated, and by how much, right? So is urbanization tied into invasion, right? Is seedling success impacted by urbanization? All these different things that if we understand how they interact, we can better build predictive models, we can better study systems that are very like poorly understood. It's just about kind of trying to standardize things and make theories, right? So, quoting verbatim from the paper, the overall objective of this study was to assess spatial and temporal drivers of forest vegetation structure and diversity in small forests embedded across developed landscapes. So, you're looking at these forests across space, meaning the plant community occupying an area, and time, or time since the community had closed up since some disturbance. So, farmland went through and then the trees reestablished and closed up. And then this is really important because temperate deciduous forests with full big trees, the climax community, are pretty much a totally closed canopy in the peak of summer. So that's how they're looking at time since disturbance as like closure of the canopy, right? And then that's going to change what plants can grow there, right? Because any understory or ground level plants in the deciduous forests are shade tolerant. Or you have plants as well that are ephemerals. Ephemerals, did I say that right? Ephemerals?
Ephemeral.
Ephemerals.
I say ephemeral, yeah.
Ephemeral or ephemeral, let us know on Instagram. These plants are super interesting where they're the first ones to bloom in the spring, and why they do that is because they're taking advantage of the time before trees totally cover the canopy and using up all the energy from the sun they can, blooming, reproducing, and then chilling out once it's dark because of the canopy is filled in. But so long story short, this study is going to help see current and over time anthropogenic impacts on these forests. Now, they found two things setting up this study. They had an urban gradient around each patch, so how much it was influenced by urban impact, kind of on the edge and then inwards. And then they also found what they called an invasive gradient, which was essentially just the density of non-native plants that were in the area. And then they have their temporal gradient, which is the time since the canopy had closed. So you're looking at three things, right? The urban influence, the invasive influence, and then the time since disturbance. And then their main questions were, how does forest canopy and understory plant composition and diversity vary with urban and invasive gradients? And how do spatial gradients relate to temporal variation? So this is, how does the community look under urban and invasive pressures, and how does that change over time, right? So they expected more natives in the canopy than on the ground floor, more invasives on the ground floor. And this is just based on previous literature that they looked into. And then they also anticipated more invasives in disturbed urban areas and tougher, more tolerant plants in more disturbed urban areas. So anybody that does kind of study plant ecology would think that these are pretty standard assumptions. Nicholas, you look scared. What happened?
I don't know what that. There's a very loud noise. I don't know what that was.
Okay, I can't hear it, but you just looked very frightened, and I was worried someone was breaking into your home.
No, not today.
Okay, not today.
I
Anyway,
have
so
several machetes lying around the house, so
there we go. You're ready to defend. Oh, goodness. All right. So the methods that they took for this paper, I'm going to do kind of the quick and dirty here for you guys. If you want to check out the paper for more, you can go ahead. But they studied 38 forests along the east coast of the United States in northern Delaware and southeastern Pennsylvania. Now, this is cool because it was actually a long-term study sites as part of a project by the USDA Forest Service and the University of Delaware. So they had like really nice data going back over quite a period of time. So this helped with studying the temporal aspects of it, right? In 2015, they sampled the vegetation. They determined their invasion gradient by non-native plant stem diversity. Now, because a huge majority, like it was more than like 95% of the non-native plants were considered invasives, they just went ahead and made the assumption to make all non-natives invasives just to help eliminate one more variable. As anybody knows, we do have to sometimes make assumptions when we're doing statistics. Then the urban influence, they used variables like population density, percentage of developed land, things like that you can assume. And then they checked to see if the urban gradient and the invasion gradient were related first. Now, this is really important, right? Because if you're taking different variables in a study, you need to check if they're correlated or related first before you go ahead and try to do stats on the overall thing. So, interestingly, they found no relationship, which this really surprised me. But so they know that you can use them as separate variables. So, it keeps getting more interesting. Now, to see how long since the canopy closure, they actually used satellite imaging starting in 1937. And I have in here in brackets, cool. And then for stats, they used various similarity indexes and matrices to compare communities and different models with the different influences and gradients, right? Go ahead and check it out if you're interested in the deeper science there. Getting into the results, on average, 65% of understory woody plants were non-native in their different test sites. So this is huge. This is a lot of non-native woody plants. It's more than 50%. However, 98% of the adult trees, so the canopy composition, are native species. So the canopy is consisting still of these native plants, which is a good thing. And canopy composition was impacted by both invasive and urban gradients, but understory was only impacted by invasive gradients.
I want to reel back just a little bit real quick. You
Yeah,
said they had satellite imaging from 1937.
apparently.
Is that do you think they mean like aerial imagery? Because the first satellite was Sputnik in 1957. So
Yes, that must be
that I'm just
aerial
curious about
imagery.
that. If
No,
it's a
no.
yeah, that's my only question. It's kind of unrelated and probably not that important, but it just was something that kind of stuck out to me as is a bit odd.
No, that's a red
And so
flag, and that's why we're here doing this together. I will double check on that, but I had satellite imaging noted down, but it must have been aerial imagery for sure that they were taking pictures of
it
these
could be
areas.
too, and it could just be a reference or like how it's referred to as well. Like they could
Right,
have said like aerial imagery and then said satellite or something at a different point in time. And also
right,
there's we do need to remember that papers are not always flawless. It could be a typo. It could
right.
be like 1987 or something.
Oh man, I'm gonna look into that because I just didn't even. I was looking at the numbers, checking the things, flew right over my head. See, this is why peer review is important, people. We need two of us here to make sure things sound right.
To check on each other. Yeah.
Check on each other, exactly. Okay, well, some type of aerial imagery was used, at least for the canopy. Thank you for pointing that out, Nicholas. It's important to critique these kind of things.
Well, I know
Um,
comment sections, and if I didn't point it out, somebody would have.
somebody would have
And
exactly.
probably not as nicely.
Maybe. So, canopy composition was impacted by both invasion and by urban gradients, but the understory was only impacted by invasion gradients. So, your big trees are getting impacted by both invasive plants and by urban influences, but the understory is being impacted just by the invasive influence. Anyway, essentially we get less difference in the canopy trees with more invasion. So this is probably that we're getting tougher trees are sticking it out. When there's a bunch of invasion, you're getting the same native trees, but the native trees that are tougher and that are better at outcompeting the non-native plants, right? By these invasive disturbances. And the big thing that we come out with is that forests with recent canopy closure had significantly more invasive species than older forests. So this is a really important one. So the ones that are newer, have been newly disturbed, had more invasive species, which is something that we definitely anticipated, right? So then what does this all mean? Like kind of what do they get into in the discussion, right? So the canopy still consists of native species. These big canopy trees are still doing well, even under all this urban pressure and this invasive pressure. So that's good news, realistically, right? The understory is filled with non-native plants, mostly shrubs and vines. So the understory in these urban habitats and these newly disturbed habitats are being invaded by understory plants. And then, super interestingly, again, the invasion gradient is not actually related to the urban gradient. So the amount of urban pressure that having more pressure and more urban influence would probably cause more invasive species, but this wasn't the case here. So that was like the main reason I picked this paper, because I thought it was so interesting. Then as well, they talked about how the canopy's okay, but the non-native understory does make it super hard for saplings to recruit. So these invasive shrubs and vines that come in are super aggressive, right? And they just like totally take over the understory. So there is a problem in recruitment of native trees. So right now we're seeing that there is a good native tree canopy, but maybe in the next couple years with these invasions that's not going to be the case, and they might not be able to recuperate. So this is something
That's what
that
I
they're gonna
just wrote down. Sorry.
No, go
I was
ahead.
gonna say that I feel like that, like, again, like, obviously they have backlog data because they had the aerial imagery from however many years, which would show that there isn't a significant difference in the canopy. However, because of the fact that trees, like large trees, take a long time to grow, we don't necessarily see the direct effects on them for a long period of time. We see the direct effects on the smaller communities, the understory, the midstory, and things like that, that have a higher turnaround rate because it's easier for to observe. But like, there might be a bit of temporal skewing to this data insofar as we don't necessarily know what the impacts could be to the canopy years down the road, because it hasn't been long enough for the effects to be visible to us.
Exactly, yeah, and it's something that has to be longer term for sure to be able to understand how this like native canopy is being effective. So for now, it's kind of positive, it's looking good, but they are really cautioning here about the fact that sapling recruitment might be super impacted by this. Like, I mean, 65% of the understory being non-native plants, right?
Right. And I mean,
Hmm.
even if they have data from, like, let's say, conservatively, they had it from the last, 50 years, most of these old growth forests and things like that, especially deciduous forests, can have trees that are well over 200 years old easily. So you're not seeing the impacts on that canopy because it hasn't changed in the time that we've had aerial imagery. So that is a caveat that I would think is probably important to talk about with this particular study, is that even though it may not look as detrimental to the canopy throughout this study, the scope of the study doesn't take into account what the old growth forest may have looked like prior to human influence, prior to aerial imagery, where some of these trees would still have even existed.
Exactly, yeah. And they do mention this here, that this study is kind of a starting point. Like, it is thankfully beginning to be a long-term study, but it's something that we need to keep an eye on, and things go so much longer than we have been able to keep track of. So it's hard for us to understand these systems in a short blip of time. So this is a good starting point, at least. The difference that they were seeing, I mentioned that there was a bunch of difference in the structures based on urban gradients and invasive gradients. So they did see different canopy trees in more developed areas. So even though the canopy didn't seem to be impacted by the invasives gradient, the urban gradient did affect it. Now, this is looking at trees that are definitely likely more tolerant of a range of temperatures, because definitely human development messes that up with different moisture and nutrients, because they tend to be quite dry around cities because of the way that we drain all the water away, that there's depletion, there's pollution. So the trees that
Heat
are
islands, too.
lasting, yes, heat islands, exactly, yeah. So the trees that are there, that they are native, but they're the tough native plants, so you're still kind of losing some of that native diversity as well.
Which we have discussed in many other episodes, that biodiversity and species diversity is just as important as the other types of diversity that I can't remember.
The forest with non-native invasions did have non-native trees. So the ones that weren't like super heavily impacted, they did have some non-native ones that were important in the community, but they weren't as heavily developed. And they think maybe because they're kind of drought intolerant. The species that they found was Acer platanoides, and it is not
Maples.
maples, exactly. And they're not very good with drought. So even though that they were invading, if there was an urban gradient, it actually helps keep them away, which is interesting. Essentially, as I kind of said already, non-native plants impacted the understory more than the canopy in the time frame that we can see, right? Now, There's actually an increase in richness in the invaded forest because of all these different non-native plants that are there, but less evenness. So you are getting a dominance of these non-native species, but it also seems that these non-native invasive plants kind of have a co-occurrence with other non-native plants, and they're choking out the native ones. So the Rosa multiflora was a big one that they found, and this seems to be associated with a bunch of other non-native plants. And so it's creating like this big community of non-native plants. And then non-native plant richness actually increased with the urban gradient, but non-natives had no relationship. So this result challenges the notion that urban ecosystems are more prone to invasions and native species decline, because the urban gradient didn't actually hurt the native species at the end of the day. So a lot of times I think we always kind of think of this as like lots of urban, very low non-native species or native species, but this paper is showing that maybe that's not the way we thought it was before. Yeah, so we're actually getting more species and more of them native with more urban impact, which is like, what? From the paper here, newer forests are more susceptible to invasion as well, which is something we talked about, which is not surprising considering like light conditions may be more favorable to understory plant growth and those kind of things. And especially native plants that are used to temperate deciduous forests, as we said, they're shade tolerant. They're used to being totally blocked out. But these newer forests that haven't established a proper canopy yet allow these non-native plants to come in and kind of take over that area. Maybe when the canopy closes up, the non-native plants will have a chance to kind of bounce back, but that depends if they haven't been totally choked out before by the other ones, right? So that is something that did go along with the expectations of the paper. And then it's likely that there's an influence of both time since disturbance and the history of an area as well here. So when they were looking at these different times since disturbance, it also depends, like, was there mining there? Was there just farming? Because these different disturbances have harder impacts on these areas as well. So there's so many. Forest ecology is, anybody that studies forest ecology, I definitely respect them because there are so many factors. And that's part of why this study, looking at these 3 different gradients, is super important to help us sort of figure out what we can separate and what we can kind of keep together, right? Now, my thoughts I have here in brackets are, once the canopy closes up and the forest does reach and maintain a climax community, that maybe in these urban areas they can bounce back, especially since we've seen that the urban gradients don't actually harm non-native plants, and they might actually foster native plants and actually foster native plants. That once we allow these forests to recuperate and reach their state, and along with obviously a little bit of invasive species control, that these inner city and like small pockets of deciduous forests between different communities will be able to bounce back to a more natural state. The conclusions from this are younger forests had more invasion. They actually found more native plants along the urban gradient, which potentially debunks the idea that urban forests don't support native life and that they always harbor invasives, which is super cool. And however, we might be worried about the canopy replenishment if these saplings can't establish. So further long-term study is required. A final note from the author, and then just a little one from me, is they said here, this is super important. In order to ensure the persistence of small forests embedded in developed landscapes, stakeholders and land managers need more support for removal of non-native invasive plants from these valuable forests, especially when they're in those early stages where we see 65% of these plants where they're not only choking out the native understory plants, but also these little saplings. And then, so even though we see this kind of good news about the urban impact not harming natives as much as we think, we really need to work on the non-native plant control. And then a super big takeaway I have from this is urban forests and urban spaces in general are super underestimated for their contributions to plant and animal biodiversity. And I think we really need to make better inner city park areas and appreciate these areas and take care of them as much as we want to the out of city areas, which obviously we have to do both. But these inner city areas do really actually foster a ton of native plants, a ton of native animals, and it's super important that we take care of them. Yeah.
Unfortunately, it didn't talk about any of the theories behind why that is, but my personal theory was that you did address the edge effect. I wrote down at the very beginning that a lack of edge effect due to the fact that there's not necessarily the edge of other non-native plants to be introduced, secondary succession from invasives is less likely due to isolated natural areas and also lack of wildlife that would naturally propagate the seeds of the invasive species. Obviously, you're still going to get birds and things like that, but the super hyper fragmented areas that are just, completely isolated from everything else. Yeah, they are fragmented, but that typical edge effect that where you get the additional invasives and things like that might not happen if they're so isolated that there's not any invasives within an area that can reach them. So that could be something. Or it was just
Right.
a
No,
theory I
that's
wrote down.
super interesting. I didn't even think of that, but that is definitely a really good theory in my opinion. That yeah, if you're just not getting the availability for these invasives to invade because they're so cut off from other plant areas, right?
Hmm.
I think a lot of maybe the theory that we have around this sort of that urban areas sort of foster non-native plants is around ornamental plants and those kind of things. But especially as you mentioned, there's a lot more controls around ornamental plants not being like fertile or not being able to propagate on their own that maybe we're starting to properly control our ornamental gardens from getting into forests. Maybe.
Maybe,
Maybe.
but probably not.
There's hope. But maybe, but probably not. One of us is hopeful, the other one's skeptical. This is it's a good balance. Yeah, so that was my snip for today. I thought it was a super neat paper. And again, forest ecology is so complicated and they looked at so many different angles here. But if you guys do take a look at the paper, you can really see that they really controlled well for the different variables and looked a lot at the different interactions to make sure everything was cut and dry. But I think it's a really good paper as a good base for us to keep studying these gradients in a different way and take a look at what we see with longer periods of time, especially in terms of the canopy. That's it from me
Cool.
today. Anything to add, Nicholas?
I've got nothing sarcastic on the tip of my tongue, so maybe I should go to the doctor.
Maybe. I guess Monday night is not our night to record, but I hope you guys enjoyed this paper. I thought it was super interesting, and stay tuned for the next full episode that'll be coming out next week.
Have a good night.